Hi everyone, we're going to find position vectors. A position vector is where the initial point starts at the origin and it ends at some AB, where A and B are scalars. We're going to represent an algebraic vector like this or like this. We'll talk about this last way to represent, this is based on a unit vector, in the second video I do after this video. So I'm going to do both ways in this video just so you get used to this representation. And the main thing you need to know about position vectors is that we can have another vector that's not at the origin, and all those vectors have a unique position vector. That means they both are going to have the same direction and the same magnitude. And this flexibility in all vectors having a position vector makes it easier, and it gives us a flexibility in working with vectors that makes it easy to use vectors in all situations. So it just makes it a lot easier to know that you can use the position vector versus another vector that doesn't start at the origin. And so we're going to do some examples, and I took the liberty of drawing a vector, and we're going to use, let me go back, this part, this here, we're going to subtract x of 2 minus x of 1 for the A component, and y sub 2 minus y sub 1 for the B component. So what we're going to do is use that formula. I'll write it down once here. So basically it's x of 2 minus x of 1, comma, y sub 2 minus y sub 1. So when we do that, we're going to get the vector equals 4 minus a negative 1, comma, and then we have 6 minus 2. And what we're going to get is our vector is 5, 4. Okay, and the other way we're going to represent this, again, like I said, we'll talk about it in the next video, is 5a plus 4j. Now I'm going to draw that, and what I'm going to do is start at 0 and go to 5, go to 5, 4. So 1, 2, 3, 4, 5, and 4. 1, 2, 3, 4. So we're going to end here. Now, our vector is at the origin, but it has the same magnitude and the same direction. So same length and same direction. All right, here's another one. So basically all we're going to do is use the formula. I'm not going to keep writing the formula down, but you're subtracting your x's and you're subtracting your y's. So we have okay, so now I'm going to go a little faster, and we're going to write our vector. Oh, I forgot to draw this one. So we have negative 2, negative 1, and 6, negative 2. 1, 2, 3, 4, 5, 6, negative 2. So there's our vector. We're starting at point P and going to our Q, and we need a position vector. So our vector is going to be 6 minus a negative 2, comma, negative 2 minus a negative 1. And that's going to give us 8, comma, negative 1. Or we could say 8i minus j. So when I draw this, we're going to start at 0 and go to 8. This was 6, 7, 8, and go down 1, So here it is. There's your position vector. Okay, this one, this is your P, this is your Q. So we're going to have the vector equals 6 minus a negative 1 and 2 minus 4, which gives you 7 comma negative 2, or 7i minus 2j. That all equals your vector. And then when you plot that, you're going to go to 7. This was 6, 7, negative 2, and go from the origin, and that's your position vector. All right, here's one, and we're going to just subtract. So we have the vector equals 0 minus a negative 1 and 1 minus 0. And that gives us 1. What did I do? No, it's 0 minus 1. Sorry, they're both positive. So we get negative 1 comma 1, or negative I plus j. So I'm going to go negative 1 to 1, and from the position vector, from the 0, I have my position vector. Okay, and the last one I have is this one, and so it's just 2 minus 1 twice, and we get 1 comma 1, which is I plus j. And again, this one right here is gonna lead into our next video. So it's 1, 1. So from 0, you draw your vector, and that's your position vector for PQ. In the next video, we're going to talk about a unit vector and adding and subtracting vectors algebraically. Have a nice day.